Okay, so today's lesson is going to deal with factoring quadratic and polynomial expressions. And then we're also at the very end going to take a look at how we solve quadratic and polynomial equations. Okay, and once you get the factoring aspect down, the solving is not really much more that you have to do. So we're going to jump right into doing some examples. This is super, super, super important stuff, not only in this class, but the techniques that we learn here, factoring, are going to be things that you learn or that you work with a lot in pre-calculus and a lot in calculus as well. Okay, so the directions ask us to factor the expression. For number one, we're given the expression 30x squared y minus 42x squared y squared. Okay, so when we look at a polynomial like this, and when we're factoring anything for that matter, the first thing we always want to check for is there a common factor that we can factor out of all of the terms? Okay, so when we look at 30x squared y and 42x squared y squared, there are three different types of factors that we have. Okay, so the first type of factor we have is a numeric factor. So when I look at 30 and I look at 42, the greatest common factor of 30 and 42 is going to be 6. So I'm going to factor that numeric factor out. And then when I look at the next type of factor, x, so we have an x squared in the first term and an x squared in the second term, I'm going to factor x squared out of the two terms there. And then when we look at our third factor, y, we have the first term having a factor of y, the second term having a factor of y squared. So the greatest common factor of y and y squared is y. All right, so when we factor that out of both expressions, we want to think to ourselves, what times 6x squared y gives us the first term 30x squared y? And that's going to be 5 minus, then we want to think to ourselves, what times 6x squared y gives us the next term 42x squared y squared? So I know to go from 6 to 42, I have to multiply by 7. And then we also have to add a factor of y there. So that's going to be 7 times y. So that's going to factor to 6 times x squared times y times the quantity 5 minus 7y. And that's all we can do when it comes to factoring that expression. Okay, when we look at the next expression, x squared plus 7x plus 10, that's what's called a trinomial. Okay, it's a polynomial with 3 terms. It's also a quadratic expression because the degree is 2. Okay, so when I look at all 3 terms, there is no factor that all 3 of those terms share. So there's nothing that we can factor out from the start. Okay, so this is the technique that I use to teach factoring. And you may have something that works better or works faster. But I like my method because my method always works. Okay, so what I'm going to do when I factor is I'm going to take the constant term, which is 10, and the leading coefficient, which is 1. I'm going to multiply those two numbers together, and that number is going to go on top. And then I'm going to take the coefficient of the x term, which is 7, that number is going to go on bottom. Okay, so what I am looking for is I am looking for 2 numbers that multiply to give me the number on top. So 2 numbers that are going to multiply to give me 10 and that are going to add to give me 7. Okay, and that's the key. Like once you figure out those 2 numbers, then factoring is pretty easy from this point going forward. Okay, so those 2 numbers are going to be 2 and 5 respectively. Okay, so once we identify those 2 numbers, what we're going to do is we're going to take the middle term, 7x, and we're going to break it up into 2 terms using these 2 values as our coefficients. Okay, So we're leaving the first term alone, x squared. We're leaving the last term alone, 10. And then we're going to break that middle term, 7x, up into 2x plus 5x. And those two statements there are equivalent. They're exactly the same because when I take the two middle terms, 2x plus 5x, that gives me the middle term 7x. Okay, so once we've taken that middle term and broken it up into two terms, we're going to use a process called factoring by grouping. Okay, so I'm going to group the first two terms together and the last two terms together. And then what I want to do is I want to factor each of those two sets of two terms. So when I look at x squared and 2x, they both share a factor of x in common. So I'm going to factor an x out. When I factor an x out, that leaves me with x plus 2. And then when I look at the last two terms, 5x and 10, they share a factor of positive 5. So when I factor that out, that leaves me with x plus 2 as well. And if you can find two numbers that satisfy multiplying to give the top number and adding to give the bottom number, then you should, with algebra, be able to make that quantity inside the parentheses the same whenever you factor by grouping, which we have. So when I look at those two expressions, they share a factor of x plus 2. So when we factor out the x plus 2, that leaves me with an x and a positive 5. So when I factor out x plus 2, that leaves me with my second factor being x plus 5. If you guys recall in the last lesson, we took a look at like how we multiplied two polynomials. So like we would multiply x plus 2 times x plus 5 using the process of FOIL. And that would give us this polynomial up here, x squared plus 7x plus 10. We're just working through the process in reverse. And when we work through the process in reverse, that process is called factoring. Okay, let's do 3 together. So for 3, we have b squared plus 6b plus 9. And when I look at all three of those terms, there is no common factor for those three terms. Okay, so I'm going to make my x over here on the side. The number that goes on top is going to be the constant term plus times the leading coefficient. So 9 times the leading coefficient 1 is 9. The number that goes on bottom is going to be the coefficient of the middle term, which is 6. So I'm looking for two numbers that multiply to give the top number and add to give the bottom number. And those two numbers are 3 and 3. So what I'm going to do is I'm going to take that middle term and break it up into two terms with those as coefficients. So this is going to become b squared plus 3b plus 3b plus 9. And then I'm going to factor this result here by grouping. Okay, so I'm going to separate the first two terms and the last two terms. When I look at the first two terms, the greatest common factor that they share is a b. So when I factor that b out, that leaves me with b plus 3. And then when I look at the last two terms, again, the greatest common factor that those two terms have is a positive 3. So when I factor out a positive 3, that leaves me with b plus 3. So when I look at these two quantities here, they have that factor of b plus 3 in common. So when I factor that out, what does that leave me with? Well, that leaves me with b plus 3. Okay, so that's going to be my next factor of b plus 3. And because we have two factors of b plus 3 times b plus 3 is going to give us b plus 3 quantity squared. Right, so that right there is that expression factored completely. Okay, let's do the same thing for number 4. So number 4 is a little bit different in that number 4 has a leading coefficient. And typically, like, these are the problems that are the most challenging to factor. But if you guys use the technique that I showed you, the technique that I showed you is going to work for all factoring problems. Okay, so I'm going to make my x over here to the side. The number that goes on top is going to be the product of the constant term and the leading coefficient. So 1 times 9 is positive 9. The number that goes on bottom is the coefficient for the x term, which is negative 6. So I'm looking for two numbers that multiply to give the top number and add to give the bottom number. And those two numbers are going to be negative 3 and negative 3. Okay, so I'm going to take my middle term and split it into two terms using these two numbers here as my coefficients. Okay, so that's going to become 9x squared minus 3x plus 1. And then we're going to factor that resulting polynomial by grouping. Okay, so when I look at the first two terms, the greatest common factor of those first two terms is going to be 3x. And when I factor that out, that leaves me with 3x minus 1. And I have to be able to factor something out of the last two terms here, which makes the quantity in parentheses exactly the same. So if I factor a negative 1 out from the last two terms, so if I factor negative 1 out, that's going to leave me with 3x minus 1. So we get the same exact quantity inside the parentheses here. So I can factor that out of both expressions. And when I factor out the 3x minus 1, that leaves me with 3x minus 1. So we have another factor of 3x minus 1, which means that this is going to factor to 3x minus 1 quantity squared. Okay, I want to see you guys try numbers 5 and 6. So for 5, you have 2x squared plus 5x plus 3 that you're going to factor. And then for 6, you have 21n squared minus 90n minus 75. Okay, I want you guys to pause the video while you work on those two, and then you can come back and we'll talk about those two together. All right, so let's go ahead and look at both of these. So for 5, again, if we're going to factor this, the first thing we always want to check, is there a common factor that I can factor out among all of these terms? And the answer here is no. Okay, so I'm going to make my x over to the side. The number that's going to go on top is going to be the product of the constant term and the leading coefficient. So 2 times 3 is going to make 6. The number that goes on bottom is going to be the coefficient of the middle term, which is going to be 5. And then I'm looking for two numbers that multiply to give the top number and add to give the bottom number. And those are 3 and 2. So I'm going to take the middle term and split it into two terms using those as coefficients. So these are going to be my coefficients for the two terms. So this is going to become 2x squared plus 3x plus 2x plus 3. And then we're going to factor this resulting polynomial here by grouping. Okay, so when I look at the first two terms, the greatest common factor of the first two terms is going to be x. So when I factor that out, that leaves me with 2x plus 3. The greatest common factor of the last two terms is just positive 1. So when I factor that out, that also leaves me with 2x plus 3. So 2x plus 3 is my common factor. I'm going to factor that out. And when I factor out 2x plus 3, that leaves me with x plus 1. So that is going to be my second factor. Okay, so that quadratic is going to factor to 2x plus 3 times x plus 1. All right, let's take a look at 6. So 6, the values get a little bit bigger here. So it's going to make factoring a little bit more difficult. But again, we want to use the same process for working this one through. Okay, so when we look at 21n squared minus 90n minus 75, there is something that I can factor out of all three of those terms. And the value that I can factor out of all three of those terms is the factor 3. Okay, all three of those terms have a factor of 3 in common. All right, so when I factor that out, that leaves me with 7n squared minus 30n minus 25. Okay, so again, we have bigger numbers here to work with, but the process itself doesn't change. So what I want to do is I want to factor that quadratic right there. So I'm going to do just like we did in the previous example. So I'm going to make myself an x. The number that's going to go on top is the product of the constant term and the leading coefficient. So negative 25 times 7 is going to make negative 175. That number goes on top. The coefficient of the middle term, negative 30, goes on bottom. And if you struggle thinking of two numbers that multiply to give negative 175 and add to give negative 30, like that's okay. It took me a little bit to figure this out as well. But those two values are going to be negative 35 and positive 5. Okay, so what I want to do is I want to take that middle term and break it up into two terms using these values that we just found here as the coefficients. So that's going to be 3 times 7n squared minus 35n plus 5n minus 25. And then we're going to factor this by grouping. Okay, so I'm going to separate 3 from everything. So when I look at the first two terms, 7n squared and 35n, they both share a factor of 7n. So when I factor that out, that leaves me with n minus 5. And then when I look at the next two terms, 5n minus 25, they both share a factor of positive 5. So if I factor out positive 5, that's also going to leave me with n minus 5. So we got what we want. The factor inside of parentheses is the same for both. So I'm just going to factor that out. So when I factor out n minus 5, that is going to leave me with 7n plus 5, which is going to be my second factor. Okay, so that right there is what the expression number 6, 21n squared minus 90n minus 75, that's what that expression factors down to. All right, we'll continue with a couple more examples in the next video.